right, so first we were given f of x, then we were given f prime, now we are given the graph of f double prime. There is only so much right now with what we have in our toolbox of calculus information to answer. So in this case, we just want to know about concavity. So remember with the increasing and decreasing, we had f prime. How did we determine where f was increasing or decreasing given f prime? What did we look at in relation to the graph? Yes, the relationship, where the graph was in relation to the x-axis. Okay, now I have f double prime. If I'm looking at concavity, we know that our function f is concave up wherever f double prime is positive. When I'm looking at this graph, how will I know where f double prime is positive? A little bit louder.
It's above the x.
Yes, we are looking to see where f double prime is above the x-axis. So we're looking here, and we're looking here. So this is where f double prime is greater than 0. Okay, what about concave down then? The rest of it. Can you be a little bit more specific?
Negative infinity.
No, don't give me the intervals, just tell me what I'm looking at.
Where is below the x-axis?
Okay, where f double prime, what did you just use? Ambiguous words to avoid it.
What did I say?
It's.
Oh.
Don't worry, it's not an FRQ. You're fine. Again, it's kind of like avoiding the word like. It's impossible. You put something else in its spot. Okay, so we're looking to see where f double prime is less than 0. And then remember, on the x-axis, that's where f double prime is equal to 0. Okay, but we haven't really talked too much about it. Okay, and then what about inflection points then? If we're looking at the graph of f double prime, how do I determine inflection points? Yeah, where the graph is going to cross the x-axis. Okay, so here, concave up, intervals, or interval, it depends. From where to where? These are all worth 1 unit. 2 to 0?
Sorry, negative 2 to 0.
Yes, okay. Negative 2 to 0. And where, I'm sorry?
2 to infinity.
2 to infinity, and this is because f double prime is greater than 0. Okay, so then concave down. Yep, negative infinity to negative 2. Anywhere? 0 to 2? Yep. And this is where f double prime is less than 0. Okay, so what we're looking at is all the inflection points. So you guys just told me that this is where the graph crosses the x-axis. Where is that? X equals? Yep. Yep. Questions? Okay. Again, right now this seems easy, but we need to go back because it is so easy to forget or confuse depending on what you're looking at. Okay, questions before we move to the graph sketching? I will tell you that we spend an entire day doing a graph sketching section. You have to know how to sketch a graph without a calculator.
For inflection points, what the justification is the f double prime changes signs.
Where f double prime changes signs, or you could say where f double prime crosses crosses the x-axis. Yes. Yep. It is a good habit to just kind of remind yourself what justification would be, even if it's not asked for. Okay? All right. So, graph sketching. The first graph that we do, I'm hoping that you're going to find it as easy as everybody else did. In the second graph, I'm actually going to introduce you to something that you have not seen before when you have to sketch a graph, so it will be somewhat new for us to conceptualize because you were never taught really how to graph a cusp. So remember we talked about where a function is not differentiable. It would be at a sharp point or a cusp. You've seen what it looks like because I sketched it for you. Now we're actually going to sketch one and see what it looks like, how you would write it algebraically. Okay, so for this first one, you have f of 3 is equal to 2. What does that mean? What is that? Oh, let's plot it then. 3, 2. Plot. Check. Done. F prime of 3. What does that mean, f prime? Okay, derivative. What's another? We're graphing now. So instead of the derivative, what else can we call it? The slope at 3 is 0. So what we're saying is, and I'm going to try to make this where you guys can see it, right here, and I'm sketching this exaggerated so you can get the idea. This is going to be basically a slope of 0 right here. Okay? Is it really going to be that long? Probably not, but just so you can see it on the graph, I just want you to see what it looks like. Now, if I look at this third part, it says f double prime. So what are we talking about in terms of our graph? F double prime. Concavity is greater than 0, so that means it's concave up. I said it. The graph, okay, for what? All values after 3, greater than 3. True? Concave up. So that means over here. So that means my graph would go, I don't know, like this maybe? So could I sketch from here, maybe something like this? That's concave up. It's after 3, right? Okay. And then the last part says f double prime is less than 0, so that means concave down for every value less than 3. So that means here. So maybe, I don't know, like this. Is this exactly what the graph looks like? I don't know. I don't have the function. I followed the directions. I followed what they said. That's pretty much all I can do. Okay, questions? Do you see why I exaggerated at this point? Okay, slope of 0, ideally. Okay. Again, we have a point. F of 3 is equal to 2. Let's plot it. F double prime is greater than 0 for x not being equal to 3. Can you interpret what you think that means? The graph is concave up everywhere except for 3, right? On both sides of 3 is basically what you're saying. Okay, so now I'm getting a picture that my graph is concave. 3 is like somewhere in the middle, okay? And then it's concave up on either side. I don't know what's happening. My head is the 0.32. Okay, so here, this is telling me that the limit as x approaches 3 from the right of f prime. What's f prime? Ooh, the slope. The slope is going to negative infinity, meaning it's just gradually getting smaller as I approach 3 from the right, meaning it's this side of my graph, true? Okay, so concave up, right, and getting smaller. I know, hard to picture a little bit, right? Okay, like this maybe? Yes? Getting smaller, but concave up. So remember what I said, you guys have never sketched a cusp before. So then the other side of it doesn't seem as intuitive because as we approach 3 from the left, okay, we're coming from this side, the slope is getting positive. Okay, but I've got to be approaching from that side, so I've got to go concave up and positive. Yes? Like this. Is it perfect? No, not by any means. Is this a cusp, though? This right here, because this is probably one of your first introductions to it, this implies a cusp at, in this case, it's x equals 3. It could be any value, so you need to take a look at it. But it also, too, you got to, like, sometimes it's hard to picture, so you got to think about it. Okay, but now you've been introduced to it. Okay, questions? We will be doing a significant amount of graph sketching with information like this